Introduction: Why disinfection matters.
Essential for controlling harmful viruses and bacteria on surfaces. By killing these microbes, disinfectants lower the risk of infections in homes, hospitals, and public places. But how do these chemicals actually work? Let's explore the science behind their power to keep us safe from invisible germs.
Step 1. Contact with the microbe.
When a disinfectant is applied to a surface, it comes into direct contact with any viruses or bacteria present. For disinfection to work effectively, the chemical needs to stay wet on the surface for a specific period, a time known as contact time, to give it a chance to act on the microbes.
Step 2. Disrupting protective layers.
Disinfectants target the protective barriers of viruses and bacteria. For example, many viruses have an oily envelope, while bacteria have sturdy cell walls. Chemicals like alcohols and bleach break apart these barriers, causing the microbe structure to fall apart and making it unable to function.
Step 3. Damaging vital proteins and genetic material.
Once the outer layers are compromised, disinfectants go deeper. They can denature proteins and damage genetic material inside the microbe. Without working proteins or intact genetic codes, viruses and bacteria lose the ability to grow, reproduce, or infect.
Step 4. Inactivation and death.
After their defenses, proteins, and genetic material are ruined, the microbes cannot survive. At this point, they're considered inactivated or dead and can no longer pose a threat. Regular disinfection keeps surfaces free from these hazardous germs, helping to protect our health.
Key takeaways: effective disinfection.
To get the most from disinfectants, always use them as instructed. Pay attention to contact time and surface type. Not all disinfectants work against every microbe, so choose wisely for your needs. Understanding how disinfectants kill viruses and bacteria empowers us to create safer environments every day.